for coming to my talk. I'm pretty sure none of you have worked with Bloxter before, so it's going to be a first approach. This is a beginner, intermediate, because usually beginners don't deal with many processes, but it's a first contact with processes, basically. I'm going to start rapidly about introducing myself. I started programming on these, and somewhere along the way I picked up C, and when I graduated as an industrial engineer, I went on to work in 2D and 3D graphics in a company that was well known at the time but no longer exists. And I'm still around. When I got kids, I quit my job, started working on what was the web at the time, doing back-end development, and then I made a total break from tech, totally disappeared from tech, and homeschooled my kids all the way to university. By homeschooling my kids, I basically became a teacher because I taught other kids, and I started teaching in after-school programs. So left engineering behind and became a teacher. PyCon 2014 was in Montreal, and I went by curiosity, and that's when I started picking Python up. And it gave me the desire to come back into tech. Could that be done after almost 20 years away from tech? From the start, 15, 20 years. And yes, I got a company called Dexter, this is a slide missing, I guess. Company called Dexter that hired me. We manufactured a little robot like that that is meant to be taken into the classroom and be used within the curriculum. So not an after-school club, not for kids who are like eating up tech and want to become engineers, but for every single kid in the classroom. So this is the little robot. And we had a lot of issues with teachers not being knowledgeable enough, and kids having to learn quickly and not having to fight with the code. So we decided to create our own language based on Bloxter. So what is Bloxter? It's created by Google, and it allows you to do a front-end block-based programming, and you can put whatever code you want behind it. There's a link here that I cannot reach because my laptop is not on the Wi-Fi. But this is what Bloxter looks like. You have a bunch of different categories. There are blocks underneath there. You drag the blocks over here, and then you can go to the tab, Python, and boom, there's Python code. All done for you. So, okay, this is our goal. We want to control our robot with it. Bloxter will be running on basically any laptop in the classroom, in a browser. But then the code itself has to run on the robot. I didn't really introduce the robot yet. This is a Raspberry Pi based robot. So the card underneath, the green card, you cannot really see. Well, you can see the bottom of it, I guess. That is the Raspberry Pi, so it's a Linux computer. It emits a its own Wi-Fi network. So teachers don't have to fight with the IT at school, and they want everything closed down. We're not even using the the school system, the school Wi-Fi. So the Raspberry Pi will be running a server, Flask in our case, and information is going through its own Wi-Fi. So what do we do now? Bloxter gives you a string that contains your Python code. It does not actually give you Python code. So for a few seconds in there, I was like, okay, what do I do with that? I have a string of Python code. Of course, I went to Google, and there's an exec function. Fine, that works perfectly. So this is like, I'm hard-coding my string, but it would have come from Bloxter. Let's drive 30 centimeters. And I need my window so that you can see it. So that's great. That works right away. However, if you have code like this, and you want to implement loops or everything like that. This is a more complex one that I'm not going to run. This is basic. That would be basically 3 blocks translated into Python. But we offer for loops. And kids in the classroom, if you give them a for loop, the first thing they will try is run it 999,999 times. So if you have exec, if you're using exec, you are in the same space as your web server. So to get out of an infinite loop, you basically have to kill your web server and hoping it will start again. And there's something fundamentally wrong about having to stop your web server to stop a robot. So exec is out. No? This is the example of the infinite loop. I'm not going to run it because then I have to actually kill it from the command line, which is not something that we want teachers to do. A lot of teachers are afraid of command line, by the way. Like really, really afraid. So, went back to Google and realized that, and I didn't know it at the time, because my background, as I said, is C. C is my native language. You can actually send a string of Python code and the command line for Python with the -c parameter here. So, okay, so if I have that, then I can use subprocess for it. And I can launch my parallel process, and it will do that. So what's the code on that one? Now, though, because I'm launching a different process, I have to make sure that this process has all the libraries that it needs, because I'm no longer sharing the space. So I have to import everything. So I have to make Blockly aware of which libraries are needed. But Blockly does support that nicely. Oh, that was a short one. Did I loop it? No, forward and back. I didn't even show you. Sheesh. Okay, so that works too, and I'm getting a process ID back that I'm going to keep track of. Because again, kids will get you an infinite loop in that process. And, no, not you. Oh, come on, where are you? Yeah. So this is the standard usage that I've seen with subprocess. You basically have your main thread, your main process, that launches one or many coworkers. In our case, because it's a Raspberry Pi, it's not a full-fledged server, and we even support the first Raspberry Pi, so it's kind of slow. It's going to be one process at a time. But most of the time, you will launch many processes and then wait for them all to finish. We don't really want to wait, because as soon as one kid clicks on the run button and watch the robot, the other kid is already programming the next part. So we want the server to be free. So we are not waiting, but we're going to keep track of that process. And if the robot is about to run off a table or something like that, we are going to actually kill it, like bombard it, murder it, with the terminate command. This is this one. And this is actually very nice if you have an infinite loop. This one is not even killing it. So process 4. So I'm keeping track of the process, getting the process ID, just for fun, just in case, and then terminate it. This one needs sudo at this point. We have little tiles on the floor here that makes it hard for the robot to drive perfectly straight. On wood it does. So we can kill it that way. Or, if the kids program normally, the process ends, but our main one keeps on going. So Linux actually has this technical term of zombifying a process. It stays there until your main process is done. But the fact for us, because it's a web server, we don't actually intend to be finished ever until there's a power down. So we have to hunt for zombies. Now there are two approaches. You could check signals with sick child and be notified when it zombifies. We didn't go that way because we already had a process in place of communicating. Basically, the browser is requesting the server, are you done? Every few parts of a second. So we're going to piggyback on that. And try not to end it. We actually have a function called hunt for zombies that will look if it has zombified, and if it does, first thing we do is actually stop the robot, and then we clean up if they have a buzzer going on or something like that. But stop is done right away. So that way we don't have zombified going on. So you can see it's my hunting going on. Boom, found a zombie and I'm killing it. As I said, we do that because this is what it looks like to the end user. We have a sensor control panel here that pulls the server continuously to display the information over there. And this run your program changes color if when it's working, and it has to go back to green. So that's why the browser is the one actually pulling that information. I'm going fast. I'm gonna have plenty of questions at the end, I guess. See, I always do that. If I present something twice, my second time is like really fast. So, can we communicate between processes? Well, using subprocess you can, but it's going to be using pipes. So you're using a CDN, a CDL, potentially a CD error. And I needed something more dynamic than that. It can probably be done. I was never able to wrap my mind around it. And as I said when I presented to Python, I was like totally glazed over and just take off and go and bake muffins and then come back later and still didn't get a solution. So I had a coworker at that time that says, no, instead of subprocess, why don't you use the library called multiprocessing? So I went, okay, that's new to me. It's not the first time I do something new. Like Julia says, if it's new, just dive in, you can do it. So we went to the multiprocessing library. And we really don't need PowerPoint at that point. Happy that I killed PowerPoint. So this is the standard usage of a multiprocessing. Whoa, what happened there? It didn't like me killing PowerPoint. Do I have to apologize to Microsoft or what? It's a hardware demo. I expected the hardware to go wrong, not the laptop. Okay, we're back. So this is a standard approach to multiprocessing library. Of course, this is like really big on the screen, so you're not seeing everything at the same time. I'm gonna make it a little smaller if I can. So you need to have a function that usually is called a worker, referred to as a worker. And that is the one that you will spawn off into a different process. And then when you call the multiprocessing library itself, you pass as the target that function. And that is an example I got from the web, and it works really well. It is fantastic. What is the issue that I'm facing? I don't actually have the code. I have a string. No. So that function at the top, the worker function, I don't have it. So how can I pass a pointer to a function that I don't have when my code is in a string? I guess I was in a good mood that day. Come on. I'm afraid if I click over there, I'm going to close the window. Not that one. Okay, so my string is a fake Blockly string that I got from Blockly. Blockly will nicely indent it for you, by the way, so you don't have to worry about that. And then we're going to wrap that code. I'm going to replace every new line with a new line tab because it's going to be under the def function. So I need to add a tab to everyone. And then I'm going to add my def at the top, def Blockly code, put my code in there. Then after that, so I still have a string at that point, but that string is now a function. I'm going to add, on line 42, another directory, another folder where I want the libraries to be imported on. And this is basically RAM, because I don't want to write to the card every single time, mainly because it corrupts the card on the Raspberry Pi, which we really don't want. And I'm going to write that code into that file. And then I'm going to import that file. But of course, if you already imported it once, it doesn't like it, so I have to reload it every time I change it. Now I actually have a function in my Python code from the Blockly, the Blockly blocks. This example, I've also added the queue, which allows me to pass messages back and forth between the two processes. So this one will actually look. Instead of having a process go zombie, I'm actually sending myself a message that yes, I'm done, Bloxter is done. Then my main process is basically waiting for any message I can get from there. And once it's done, I join and I quit everything. So this is multiprocessing 4. There's really not a lot of real estate on that screen. So you can see that I'm getting messages back from that string, that code in a string, and Bloxter is done. So that's the way we went with. This is what we eventually shipped. And coming up, first of all, we're going to move everything to Python 3 because multiprocesses are so much better in Python 3. I had to cry a few times because I was dealing with Python 2. So we're moving to Python 3, and we are also going to be supporting parallel Blockly code eventually. Right now we only have one, but the goal is to have many. So this is what it looks like when you actually run Blockly. So it's going to go forward until it gets, it's pointing the wrong way, until it gets to the wall, detect the wall, and then back up as a truck. Well, bye-bye. Well, it actually comes with the end of my talk. Second time around, I'm so much faster than the first time. But it gives you an idea of what we're shipping to beginners and how you can handle the code with Blockly and Python. Thank you. There's time for questions.
Thank you very much, Nicole. That was a great talk. Are there any questions for Nicole on the talk?
On the talk or the robot?
Or the robots, yeah.
Yes?
I did have one. Sorry, I didn't quite follow the reason why you need to write out the Python code to another file so you can import it.
Because I don't have Python code. I only have a string.
But isn't the string Python code, or maybe I missed something there?
It's actually a string variable. So how do you execute a string variable?
Yeah, sorry, I must have missed that part.
Okay, that's what you get back from Bloxter. It's just a string.
I see.
Okay? Yes?
Could you attach the string into an already defined function and run exec on that in a function that you pass?
That's actually, we thought about it, but this was done already, and we saw no reason to actually change it, but it's it's another possible solution. No?
Any more questions?
Yes?
What was the original reason for using Python?
Legacy code. The fact that we've never actually moved the company to Python 3, but we are now. No. Yes? Oh yeah, sorry. The question was, why was it done in Python 2? The answer is mostly legacy code.
Yeah. No, my question was more, could you give a few examples of how you use the robot in the classroom?
Yes, of course. Well, of course, there's math. That's the obvious one. So we have a teacher who does the number line. So if you go forward 2 inches and then you go backward minus 2 inches, where do you end? So that's one thing. So this grade 6, usually grade 5, grade 6. So they start, subtracting negative numbers. So that's one thing. In a social science class, they wrapped up the robot into a transport mode because they were studying the Conquer the West, the Conquer of the West. So they had to build on the robot something that made it look like a caravan or a horse or whatever. And they had a huge map of the US in the middle of the class. And then they had to code their robot to cross over, avoiding the pitfalls based on their vehicle. Okay, so that is another one. We have a Mars Rover project that you can use. So it will send you pictures. It's a Raspberry Pi. It comes with a camera. You can actually take pictures with it. So the robot is in another room, and you control it from a distance. You have to code it, and you get the pictures back, and then you have to interpret the pictures as if it was on Mars. But the main advantage of the robot is that it is accessible out of the box, as opposed to Mindstorm, where you actually have to build it. So if you want it inside of your classroom when you're limited to just an hour, this is easier to handle. Yeah? We have tons of sensors that you can add to it. I mentioned the camera. We're coming out with an IMU so you can make it behave like an airplane and detect if you're too high and you're going to tilt over. It will detect north and south, so you can actually give it a heading and it will go to that heading. We have a GPS with it. Light and color sensor. You heard the buzzer when it was backing up. It really supports a lot of sensors. Plus, you can add our other product, which is called the BrickPy, which gives you access to the Mindstorm sensors. So, sky is the limit with the robot. Yes?
So, my kids are in grade school, so how do I get you guys to bring your robot and work with that when kids elementary school?
Yeah, well, the company is an American company, unfortunately, for us, fortunately for the Americans. I'm the only one in Canada. Okay, so I do sometimes do a workshop with my robots. I am doing right now with homeschool kids. Other than that, you have to buy the robots, but you will not get a teacher. Okay, so you have to convince the teacher in your school. The robots are available in Canada, but it's mostly in the States, and they're not available in French.
So in the US, is the company going to grade schools and trying to get them to?
No. Well, we're not going to grade school to teach.
No. Get them to buy it.
Oh yeah. We have, I think it's 4,000. No, of them sold in the States. We sell actually all over the world. It's the States, and the second one is, I think, is Israel, but don't quote me on that, I'm not sure. No? So. Yep.
So take this track program, right? That's a pretty complicated program. Or not that complicated, but it has a bunch of...
This one?
Yeah.
No. Oh, by the way, I didn't show you, but for those who want to cheat, if you go into the console, somehow the Wi-Fi here is like killing my Wi-Fi. You get the Python code.
How long would you expect it to take like a beginner kid to like write a program like that using Bloxter?
Okay, so killing this. We actually have a learn mode that will take you through lessons. So, and we will even give you steps on how to do it. I'm going to skip the steps here. See, this one actually only has one block. Okay? Now, because of the resolution, we lost the goal that you're supposed to do. This is fixed in the next version. You're going to be losing the title, but you're going to get the goal. So you just, you handle one block in this one. And then next lesson, you're going to be adding more and more. So we build up. So even the teacher can basically just give the robots to the kids, and they already have about 4 or 5 hours worth of lessons, depending on how many sensors that they have. No? The robot itself is not limited to Blockly, by the way. It supports it's a Raspberry Pi, so we support Python, C#, Java, Node.js. I'm missing one. But anyway, we support a lot of languages and a lot of sensors, and the robot is used all the way to master's level by people who don't want to have to spend time maintaining their own robot, and they just want to move on to do machine learning. We have an application where the robot takes a picture, sends the information to the Google Cloud API, and gets information back from it to display the emotion that is seen in the picture, or identify the objects. That was Google who came up with that. And we were like, what is Google doing with our robot? So they're using it to showcase their project, but because it works out of the box, they can move on to what they want to do. So that's why we have people doing a master's thesis using our robot.
Any further questions?
I think you had one?
Where can you buy the robot is the question.
Yeah, Amazon.ca will sell it. It may not sell all of the sensors though, but you will have the base robot definitely. Right?
What's the difference between this and the Scratch made by MIT?
What's the difference between Blockly and Scratch made by MIT is a question.
Yeah, Scratch in itself is a whole programming language. Blockly is just the front end, and you have to provide your code behind it as a developer. Right. Most of the time, Blockly is used with JavaScript, and they stay in JavaScript. Okay? So it works in a browser, right is. So and Blockly and Scratch are kind of merging. The next version of Scratch will be done with Blockly. Because Blockly is just the front end, it's just your tool. So if you have a project where you have users, they need to make a couple of blocks, you can use Blockly for any project. It doesn't have to be limited to kids.
Thank you very much, Nicole, for the great talk.